Alright, this is chapter 1, lesson 3, and we're going to talk about continuity. And we're actually going to really start getting into limits. I would get used to limits quite a bit because when you get the calculus, limits is a very big deal. So, what we're going to do is we're going to use limits to determine continuity of a function and apply the intermediate value theorem to continuous functions. So, okay, this is a long page, but I took this exactly out of the book, obviously. So here we go. The graph of a continuous function has no breaks, no holes, or no gaps. You can trace the graph of a continuous function without lifting your pencil. So basically, hopefully I don't lift it up, but you're just tracing it and the pencil never comes up. There's no break in the graph. One condition for a function f of x to be continuous at x equals c, just c's the number, is that the function must approach a unique function value as x values approach c from the left and the right sides. It seems like a lot, but all it's saying is, if I wanted, the other day when we had like f of 2 or whatever, and you'd go to 2, and then you would go up to the graph and find a number, it's saying, if you're at the number c, these numbers, if you're plugging them into the function, is also going to be approaching f of c. It'll make more sense as the video's going on, but it's finding the value, approaching it, not just plugging it in. So, the concept of approaching a value without necessarily ever reaching it is called the limit. Mean Girls, the movie, has a big example of the limit when she's at the Mathletes Bowl and she basically goes, the limit does not exist. We'll get to those. We'll do a lot of limit not existing. But the whole point of limits is, as it approaches a value on the domain, it's going to be approaching a value on the range. And if they're approaching the same value, then you have a limit. If they're approaching different values, then you don't have a limit. So, here we go. So, the continuity test to determine if a function is continuous. Number one, the first way to do it is easy. You plug it in. If you plug it in and it works and it's all good, and then you have a limit. The next one is using the graph, which I'll do an example of. And then the third one is the same thing. It's with the graph. So here we go. Determine whether f of x equals 1 over 2x plus 1 is continuous at x equals 1/2. Justify using the continuity test. So we're going to do the first thing very easily. F of x equals 1 over 2x plus 1. So f of 1/2, because that's what it's asking, equals 1 over 2 times 1/2 plus 1, which equals 1 over 1 plus 1, which equals 1/2. So, it's the same number for this problem, but x equals 1/2, and so when I plug it in, f of 1/2 equals 1/2. So far so good, it is going to be continuous at 1/2. Now to the limit part. Alright, so we're going to investigate. So what you do is you make a t-chart, and I'm going to do it sideways because it's just easier to tell. Alright, so we're going to say 1/2 because x is 1/2. So what you're going to do, it might help better too, here's 0.5. So what you can do is we can say this is 0.4999 because that's really, really, really close to 1/2. And we can say this is 0.49. And then this side, so we have 0.5, we can say this is 0.5001. We can say this is 0.51. So we use the table of numbers to figure out if it's approaching it. So yes, there's going to be some calculator work, but that's okay. So let me get the calculator ready. Okay, so 0.49 for x is going to be 50 over 99, which is 0.5050. Alright, 0.4999 for x is going to be 0.500000, and then all of a sudden a 5 pulls up. Don't plug in the 1/2. So now we're going to go to 0.5001. 0.5001 approaches x. So I get 0.4999, and 0.51 approaches x. 0.49504. All right, so what we did is we're looking at it as it approaches the continuity test. So as I'm getting really close to 1/2 on the left and really close to 1/2 on the right, we're looking at the range values, and we're looking at the range values, and we're looking at as it's approaching. And so obviously we can say 0.500005 and 0.4999 equals 1/2. Okay, so what we can say is, as the limit x approaches 1/2 of f of x, we can say as it approaches it, then the answer is also 1/2. And then the last test basically says, right here, if the limit of x approaches, the arrow means approaches 1/2, then f of 1/2 is going to be the answer. So f of x equals f of 1/2, which is obvious. F of 1/2 is 1/2. So let's go to the next thing.